Hello and welcome to the second video in the Building Your Own PC guide. This is Greg from Reader Programming, and let's get started. Well, before I get started, I just want to ask you, the viewers, if any of you are aware of a good program that I can use to create these PowerPoint presentations, because um, this is now the 8th video that I'm trying to make, and up until now I've been having a very, very big problem with trying to get it to work right. I've been using Fraps up to this point, and that doesn't work at all. Now I just spent some money on a program that's supposed to do it, and I get the problem that every once in a while the voice gets really slow and then speeds up again and then gets back to normal. Um, I'm really frustrated with this since this is the 8th time I'm doing this presentation. So, any suggestions, please let me know. I'm really sorry about the crappy quality of the sound. At this point, I'll just be happy if it works. So, let's get started. What we're going to be doing today is talking about the components inside of the computer case. We're going to be discussing what you need to watch out for when you're building your own computer, and I'm going to also take you on a brief tour of what I'm getting. Well, maybe not specifically what I'm getting, but generally what I feel I want to get and how I can best help you in your search for your components. In the last video, what we discussed was whether or not you actually should build your own computer, or if you should just buy a pre-manufactured one. What pretty much came out of that was you really need to think long and hard about what you want to do. It really sucks if you want to, well, if you say that you want to just have a computer where you're just going to do school stuff on and internet research, and then find out 2 months later, oh, well, it doesn't play my favorite game, so I hate this thing, and then have to spend later on even more money getting a computer that best fits your needs. You're better off really being honest with yourself and getting the computer that really is perfect for you. I personally decided that I did indeed want to build my own computer, and I wanted to do this for a couple of reasons. One, I am really tired of going into stores, seeing all of these computers that are really expensive, and not a single one of them fits what I want to do. That one thing alone was a main deciding factor in this. Secondly, because I am involved in information technology, it just seemed like the logical next step. I'll briefly tell you what I am planning on doing with my computer. First off, is gaming. I love playing games on a computer. I've done it since I got my hands on my first one at the age of about 16, and it wasn't my computer, it was my mother's. And I made the mistake when I was about 20 that I spent money on a computer thinking, oh, I wasn't going to play many games, and about 5 months later I was really disappointed in the lack of ability that it had. So, yeah. Learn from my mistakes. So, let's really get started. More specifically, what are we going to be discussing today? Well, let's take a look at a list of all of the items inside of the computer. I'm going to tell you briefly how I'm choosing them, what you should look at, and more importantly, what they are. Then I'm going to be getting more into the particulars of what a CPU is, how to choose it, different options available, And then I'm going to do almost the same thing with the motherboards. What parts are inside of a computer? Well, we have the central processing unit, we have the graphics card, and we have the motherboard, RAM, hard drives, the housing, the optical drives, and the power supply unit. One thing that I really want to tell you, and this is a bit of a tangent, so please bear with me, is I've heard a lot of people say that the CPU is the brains of the outfit. That, I'm sorry to say, is inaccurate. In in order to really go into this metaphor that a computer is a simile, that it's like a living biological creature, you'd have to say that the CPU is only one hemisphere of the brain. It normally only does the logical computations and does not do the graphical stuff. The graphical stuff is taken over by the graphics card, which I would like to say is the other hemisphere of the brain. The motherboard would really take over then the structure of the brain. More specifically, it would be the corpus callosum, brainstem, maybe even the hypothalamus, and all of these components together would make up the brain. Just a little bit of a tangent, probably confuses most people out there, but I really find it a cool thing to compare the computer to a human body. The random access memory is the short-term memory. Basically, the way it works is that the zeros and the ones are saved electronically on RAM cards. And these zeros and ones need to be continually refreshed in a specific tact. And once these cells are no longer refreshed, it no longer contains any information. So that's why when you turn off your computer or restart your computer, the RAM is completely flushed clean and everything is erased. The hard drives are the long-term memory, is the long-term memory of your computer. There are two basic forms of a hard drive. Basically, it's magnetic or flash. Magnetic memory is the least expensive of the two. It's been around since forever, and the flash memory is not overly new, but in comparison, it is pretty new. Flash memory works in that there is a very large array of micro batteries, which are either charged or not, which then translates into a 0 or a 1 in binary language. A USB stick is nothing else than flash memory, and they have been able to make hard drives which are, again, using flash memory. So a really cool thing. They tend to be a lot more expensive and a lot smaller than the magnetic hard drives. At the current moment, the largest internal hard drive that I saw magnetic was, I believe, 4 terabytes, and the most common was only 3 terabytes. But I'm pretty sure I saw one 4 terabyte hard drive. The largest flash memory hard drive, they call them either SDD or SSD. Sorry to say, I forget which one is the one that it's called. The largest one of them that I saw up until now is only 400 gigabytes. Doesn't mean that that's the highest, but that's the highest that I personally saw. And that was round about I believe, €300 as opposed to 150. So, pretty big difference. The housing or the case is not that hard to choose. You have to look at what size of a motherboard you have and any other special requirements you have, such as aesthetics, how many bays it has for the hard drives and the optical drives. So really have to just think about what you want. I personally put the amount of hard drives way ahead of as far as importance is concerned, the amount of bays for hard drives for me was a lot more important than how it looked. The reason for that is I plan on running multiple hard drives at once and multiple operating systems singularly. So I want to be able to have, in essence, three computers in one. I want to have a computer that runs Linux. I want to have a computer that runs Windows XP because I have a lot of older games that I still really enjoy. Anybody who knows KOTOR, Knights of the Old Republic, the originals, not the current one, but the originals, will know. Fantastic game, runs very well on XP, but on Vista and on Windows 7, not exactly the best. So I want to have one computer that runs XP for the older games, and I also want to have the newest of the Windows, either 7 or 8. 8 isn't available quite yet, but is coming out soon. And then I want to also have a very large capacity for test environments. And this is going to be done by way of virtual machines so that I can very quickly delete them without having to worry about reformatting any drives or anything like that. So there's going to be multiple virtual machines running at the same time. What does that translate as? Translates as a lot of RAM. I'm going to be maxing it out at about 32 gigabytes. I'm going to need quite a bit of hard disk space. And because I'm dealing with so much memory, I want to use RAID to back up the hard drives onto other hard drives. I'm going to be getting into RAID in the next video because I find that it's a very important option, especially when we're talking about hard drives that are up to multiple terabytes. If one hard drive fails, there's going to be another to back it up. I'm not going to go into RAID in any more detail right now than that. I just wanted to let you know that as part of the reason why I'm looking into getting so many hard drives. I want to have at least 4 in total, so 2 backup, 2 actual, we'll say main hard drives, and the possibility of a 3 to 6. So that was probably that was my main difficulty in finding a proper case. The optical drives are another thing that you're going to have to look into. Optical drives are the CD, DVD, and Blu-ray. Pretty much they work with a laser, and then the computer can actually see how the bits are set up, what's a 0, what's a run visually. I wrote floppy here because of the very slim possibility that you're going to want to use one of those old things. I haven't seen one in use since 1999, so 13 years ago. Was cool back then, but now a $2 USB stick has way more memory capacity. Just trying to say it's a possibility. Haven't seen any use for it, except for if you maybe want to run some very old DOS game. Power supply unit, that's the last thing that I'm going to choose. I didn't even look into most of them because what I want to do is gather everything I have, what I'm going to be using, and then calculate how much all of that in watts is actually going to eat up. And only then can I really look at what specific power supply unit I can get. This is just a really quick diagram of how all of these parts fit together. What you see here is one very large rectangle which represents the case. And on the bottom left corner, you're going to see the power supply unit. You see that this PSU supplies electricity to the motherboard, to the optical drive/drives, and then to the hard drives. The motherboard then contains the CPU, the RAM, and the graphics card and delivers power to them directly. And the information is read from the optical drives and the hard drive by a cable. The CPU is, as I said, like one of the hemispheres of the brain, mainly controlling the logical computations. I wrote here that the CPU performs all non-graphical computations, but that's not entirely true. The Intel i7, from what I have read, is capable of performing moderate graphical computations in itself. The idea behind that is to make things a lot faster. If one hemisphere of the brain can think logically and imaginatively, then it's not going to be so dependent upon the method of sending the electrons all the way over to the graphics card just to figure out where to place a certain window on the screen. So it makes things faster. Put in another way, fastest way to send information across the corpus callosum is to do everything in one hemisphere. Really cool thing about the central processing unit is that it is found, such processors are found in so many current devices that you really may not even think about it. Some electrical toothbrushes even have readouts with some sort of a microprocessor, which is nothing more than a CPU in small form. There are even CPUs in some coffee makers, the ones that you can program to start at 7 o'clock so you wake up to the smell of a wonderfully delicious strong brew rather than listening to the heart attack inducing alarm clock. That type of coffee maker will have some sort of a microprocessor in it. Some televisions even have some. Some alarm clocks even have a microprocessor. Even a car will have some sort of a CPU inside of it. So really cool, really popular, heavily used. It's also the first thing that I chose. Makes things a lot easier. My main problem was that I didn't know where to start. There's so many different parts that you have to look into, and each decision affects the available choices for the next part. It was really hard for me to decide where to start. And I ended up starting with the CPU, and I really highly advise everybody else to do the same. I chose the Intel i7, which has the socket size of 1155, and then I had to get a motherboard that had that same socket size, so it made things a lot easier. Once I chose my motherboard, then that decided which type of case I should get, and so on and so forth. So CPU, great place to start. The other thing when you get into CPUs and deciding, alright, what do I get? you have to decide which brand to get. And there are two different main companies, AMD and Intel. Intel is the oldest. It's been around for decades. I guarantee it's going to be around for a few more decades to come. And I'm really pleased with their work. I really am. AMD is newer. It's, well, I've looked in a lot of forums, a lot of reviews, and as far as I can tell, it's fanaticism as far as who thinks what's better. There's a lot of people who think that AMD is best. There's a lot of people who think that Intel is best. There are people who think that AMD is cheaper and performs just as well. There are people who say the exact opposite, and I really do not want to get into that debate. From my personal experience, I'm just going to say that my personal opinion, stressing opinion because I can't really back this up with quantifiable statistical data, I'm going to say that AMD is best for those computers which are going to be mainly business oriented and not really computation intensive. So programs that use a lot of Word and a lot of the other Microsoft stuff should be fine with AMD. If you're doing games, I personally think Intel is best for that. But again, that's my personal opinion. Don't quote me on it. Make up your own mind. Read as many reviews as you possibly can. Don't take my word for it. Alright, here we have a picture of a motherboard. The first time I saw a motherboard, I was really overwhelmed with all of the different things available. It also seems very magical, or seemed very magical to me. So, yeah, I was very overwhelmed with all of the different parts on it. We have, for example, the CPU socket, we have the RAM, we have the North bridge, we have the South bridge, we have the PCE slots, we have Helm's Deep, Mordor, the Shire. We have everything possible you can even think of. So I'll break it down now and just tell you the most important parts that you might want to take a look at. I'm just going to start on the upper right end of the board. I can't really tell you with all certainty what all of these rectangles are because I cannot see the profile. However, if you look in the upper center, you'll see one metallic and rectangular thing with a blue and orange nubby thingy. That is the sound input-output slots. Next to that are two rectangular metallic slots, which I am pretty certain are the USB input-outputs. Aside from that is the Ethernet LAN switch input. I am assuming that next to that is the FireWire, but I'm not certain, and I really cannot say at all what the other two are. I could tell if it was showing the peripheral, but in this picture I really can't tell you. This is probably a very important part in motherboard selection, as you need to decide what is important for you, what it is that you want to have, and decide if that motherboard has it. If you look a little bit further down, you're going to see two multi-blue colored rectangular fancy looking thingies. That is for heat dissipation. One is going left to right, one is going up and down. This adds more surface area to the board so that when the air from the fans passes over it, it can dissipate more heat. Basically, more fins equals more surface area equals better heat dissipation. Inside of that square that's formed by those two heat dissipators, you're going to see a little hatch. And inside of this hatch, you're going to see two goldish brownish L's. That's where the CPU is going to go. This area generates a great deal of heat. Inside the CPU, there are, by now I believe, millions of tiny transistors and little wires, and the electrons have to pass through these wires. And what happens is the same phenomenon that happens with a light bulb. Lots of electrons pass over a filament in the light bulb. It gets hot. The light bulb gets so hot that it glows. And if it gets too hot and stays too hot for too long, it burns itself out. When you have a CPU that costs quite a few $100s, you can't let it burn out like that, so we have to dissipate the heat and keep it cool. That's where, and the motherboard itself even. These fins that you see help keep the motherboard cool, and on top of the CPU is going to be something called a heat sink, which is going to keep the CPU as cool as possible. That's also why if you do CPU overclocking, you really do risk burning out your CPU and even the board itself. So if you're going to do overclocking, make sure you know what you are doing. I'm not even going to risk playing around with that. It's like playing with fire. I don't want any part of it. Further down from the CPU socket, you're going to see four rectangular slots, two blue, two black. And this is where the RAM goes. These are for the RAM cards. This particular motherboard has two channels for RAM and offers a maximum of 32 gigabytes worth of RAM space. I don't know why anybody would need 32 gigabytes except for if they're running multiple virtual machines at one time. I believe even the best games nowadays don't even require more than 8 gigabytes, and if you have 16, that's more than enough. So, a little bit further down, all the way at the edge of the board, on the left side, is a blue socket. That's where the power is going to be coming in from the power supply unit. To the left of that, you see four small cube-like slots, two light blue, one dark blue, and one white. Those are the SATA input slots where we're going to be plugging in the wires that go to the optical drives and to the hard drives. I was looking at this particular board because I wanted to purchase this one. However, I ended up not doing so because it didn't offer enough SATA ports. If we look above that, towards the top of the board on the left side, there are four smaller blue slots and two longer ones. The longer one closest to the CPU is where we're going to be plugging in the graphics card. You could possibly, from what I understand, insert a second graphics card into the other slot. I don't think that's really necessary in most cases, but I have heard of people doing so. And these other slots are if you want to add any other extra things, more USB ports, etc. Pretty cool stuff, actually. On the left edge of the motherboard, there's a lot of metallic pins. There we're going to be plugging in things like fans, the wire that goes to the on switch on the tower, is going to be plugging in over there, and I believe that even some LED lights could be plugged in there, but I'm not too certain about them. The motherboard, as I said, acts as the structure of the brain. I wrote here that it acts as the brain stem. When I talk about that, I'm mainly referring to the BIOS. The BIOS is the basic input-output system of the machine, and it's going to be able to boot up the computer. It's going to know, okay, I need to search in that hard drive for an operating system so that I can actually start up. And it also takes on a lot of the automated actions of the system. So that's why I say it's like the hypothalamus/brainstem of the computer. Really important stuff. I wrote here that the motherboard does not calculate anything. Again, I'm going to say that's only true from a certain perspective, because if you look at the BIOS, it can perform very limited calculations, but nothing as far as what the CPU is going to do. Motherboards do range in shape and size, and part of this is based upon a lot of these standards are going to also vary by, I believe, CPU slightly. But there are standards. Most popular is the ATX. As I said, socket size directly affects what motherboard you can get. I wrote here it directly affects the CPU, or is affected by the CPU. So you could also choose your motherboard first and then go for CPU. I just think that that's really a stupid idea, though. So choose your CPU, then choose your motherboard. Keeps it simple. ATX is the most popular standard. There are multiple ATX standards, though. There's the mini ATX, which is pretty small. Then there's the E, or extended ATX, and that's actually what I ended up getting. I wanted to have the maximum amount of slots for extensions, and I also wanted to have the maximum amount of hard drive SATA ports. When you're selecting your motherboard, you're also going to want to take a look at how many RAM slots it has. Generally, it only has 4, but the amount of memory capable, the memory capacity, and how many channels it has. I really only know of a motherboard having 2 channels for RAM. I really can't tell you the advantages or disadvantages. Pretty much all I can say. One other thing that you're going to want to look into when you're selecting your motherboard is our special features of the BIOS. Most important one that I can think of is, again, RAID. When you're building a system that has multiple terabytes of information, if you lose one hard drive, you lost an immense amount of data. Almost incalculable. Well, obviously you can calculate how many it is, but hard to imagine how much information would be lost if one 2 terabyte hard drive goes to its grave. So when you're dealing with so much memory, so much space, you're gonna want some sort of backup, and I find RAID a very awesome feature for that. And as I said, we will be doing that in the next video. I just quickly want to thank you for your attention and for watching this video. I hope that it's a lot better than the first one. Again, I'm really sorry about the first video. That was terrible. I'm also hoping that the tone quality in this video is good. I fear that there are places where it's going to turn out horribly. That just is regarding my software here, which I am very disappointed in. And if anybody has any suggestions for a better software that I could use for this purpose, please let me know. Um, if you have any questions, if you have any comments, again, please drop me a line. And for teachers out there who are wondering if they can use this presentation in their classrooms, the answer is yes. And if you want me to kind of redo it so that the swearing's gone, I'll do that too. Just let me know. And thank you very much for your attention, and I'll see you next time. Bye.